Hello and welcome. I'll be discussing my solution for number 1 of problem set 2. So in number 1, we're asked to find the total resistance of the given resistor ladder network as shown, given that every resistor is equated to 1 ohm. So what I first did was to simplify the circuit by making this delta formation here and here a Y formation. So to make it a Y formation, I first drew this guide so that I could find the resistances of this resistor here, here, and here. So for solving the resistor or the resistance for this, same as here, we must multiply the adjacent resistances from the delta formation, which is 1 and 1. So we got that for 1 times 1. Then we divide this value by the total, or the total resistance of the delta formation, or like the sum of their resistances. So 1 plus 1 plus 1, which gives us a value of 3. So the resistance of this resistor is equals to 1 over 3 ohms. So since the whole circuit has an equal resistor, so I assume that the resistances of the Y formation would be also the same, since they just follow the same formula. This is what it looks like after converting one delta formation to a Y formation. So this is the second after converting the two delta formations to a Y formations. So in this part, we could see that we could simplify it even more. So what I did was I combined these two resistances, since they're just connected in series, then make another Y formation here. So that would give me a 2 ohm resistor in this connection. So I use this delta formation again, then convert it to a Y formation. Then again, I draw my guide so that it would be easier for me to solve for the Y resistances. So for this resistor, we multiply this adjacent resistor from the delta and this one, then sum up all the resistances of the delta formation. So by doing the formula, I got these values. So for this resistor here, its adjacent resistance in the delta is 1 over 3 and 2. So I multiply them and divide them by the total resistance, which is 1 over 3 plus 1 over 3 plus 2. So I got 1 over 4 ohms. Same goes for this, since its adjacent resistances is still 1 over 3 and 2. So they got the same value. But for this one, its adjacent resistances is 1 over 3 and 1 over 3. And then again, I would multiply those adjacent resistances and divide them by the total number or the total resistance of the delta. Then I got a 1 over 24 ohms. So after converting that delta formation to a Y formation, I put it in the circuit. So here we go. There are no more delta formation that can be seen in the circuit right now. So the next step would be to sum up the resistors or resistances that are in parallel. So here is the default value of resistance, which is 1. So I add it to this resistor here, 1 over 3. So I got 4 thirds ohm, or 4 over 3 ohms. So for this one, 1 over 3 plus 1 over 3 plus 1 over 24, then the total resistance for that series would be 17 over 24 ohms. Then here 1 over 3 plus 1 plus 1 over 4 would be 19 over 12 ohms. Then here 1 plus 1 over 4 would be 5 over 4 ohms. Since that is all add up or summed up, I redraw the circuit again. So this is I think this is the final part of the process. I will be adding these parallel resistors so that it would be so that the final circuit would be only a series circuit. So in adding parallel circuits or parallel resistances, there is the Ohm's law, which is 1 over the resistor, the first parallel resistor, plus 1 over the second parallel resistor. Then we got a total resistance of 323 over 660 ohms. Then after that, it would be a very simple circuit which only composed of a series resistances that are in series. Yeah. So you just add up the 4 over 3 plus 323 over 660 plus 5 over 4. So the total resistance of the whole circuit is equals to 3.07 ohms.